Quadratic function is really a subset of the polynomials. So we're just going to talk real quick about polynomials. Polynomials are made up of many terms. The terms are added or subtracted. And the terms are made up of variables with exponents. Their exponents have to be whole numbers, 0, 1, 2, 3. And they might also have a coefficient in front of them. Okay. And so polynomials get classified by their degrees. The lowest degree polynomial, let me fix this, is the constant function because it has a degree of 0, and anything raised to the 0 is what? 1. So if you had something x to the 0, it would just simplify to be 1, and then it'd multiply by its coefficient, and it would just be that value. Doesn't really help very well. So we have the constant function, we have a linear function, quadratic, cubic, and we even have names for fourth and fifth, quartic and quintic. After the fifth degree polynomial, we just kind of simplify our lives and we start calling something a sixth degree polynomial, a seventh degree polynomial. Remember in geometry when you used to go up to like a dodecagon, and then you just started calling things like 13gon? Okay, same idea here. And then the quadratic function is anything with degree 2. So as I was moving around the room, I heard a lot of you saying, well, we know it's quadratic. We know its parent graph is f of x equals x squared. And then maybe you talk about some of the transformations from that parent graph. So you recognize it as quadratic. Okay. What do you know about the shape of all quadratic functions? Brady? What do you know about the shape of all quadratic functions? Why are you whispering? You want everybody to know how smart you are? You don't want to intimidate people?
Sure.
What's true about their shape? What do we call it? A parabola. Is that you making all those noises? Who's making all those noises? You, Elias. One of you's coming from the
Whoa. Okay.
It's one of you. You know the little, like, yes, who does that? You? See, he makes all the noise, but he won't answer a question. Then he whispers it. You want to be heard, so I called on you. Then you don't want to respond. Ugh, trouble. Okay, so think about the warm-up and what you and your group talked about. Did you say any of these characteristics? It's a parabola. It's U-shaped. Did you talk about or reference the direction that the parabola opens, up or down? Okay. Did anybody mention a vertex? And maybe in terms of transformations, you talk more about left, right, up, down. Okay, but by doing that, you identify where your new vertex would be. A huge part of the modeling of quadratic functions is that the vertex is your minimum or maximum value. Okay, so that's really helpful. Axis of symmetry. Axis is just a fancy name for line, so it's the line of symmetry for your quadratic. The line of symmetry always passes through what point? The vertex, right? It folds over at the vertex, and then the parabola maps onto itself. I call this AOS, so if you ever see me write AOS, I'm referring to axis of symmetry. Okay? And it should be a vertical line because we only have parabolas right now that open up or down. We will have some second semester that open left or right, and then they won't be functions anymore. X-intercepts is also something that we're very curious about. We talked about on the very first day of class, what does it mean to find zeros of a function? And you guys talked about in your small groups, oh, it means to find the x-intercepts. So now I want you to talk in your small groups. If I ask you to find the x-intercepts for any function, what do you do? So good things to talk about with your group would be, what does it mean to be an x-intercept? What do you know about all x-intercepts? And how do those two things help you decide what you would do to find x-intercepts? So devise a plan in your small groups, how you find the x-intercepts of any function.
For real though? So
Algebraically.
he's
Clarifying.
break.
Algebraically, how do you find that intersection?
But I do know a rule in which the amount, like the maximum amount of x-intercepts of any polynomial is 1 minus the biggest exponent.
You come up with a plan?
Yeah. So that's the maximum that it can have. It doesn't mean it has to have one choice. That's the maximum amount of x-intercepts. Which x-intercepts can be the little line squiggly thing goes through.
Okay, let's come together algebraically. How can you find the x-intercepts? Jenna?
Put 0 in for y and solve for x.
Okay, put 0 in for y. And solve for x. Good. This is standard for all functions in mathematics. If you ever want to find an x-intercept, that's really all you got to do. Make your y value equal 0, and then go ahead and solve for x. Did any groups talk specifically about quadratics and how you solve for x in quadratics? I didn't really hear anything. A lot of times, like when you think back to Algebra 2, you could say quadratic formula, you could say factoring, there is a method of completing the square, and the one that we're actually going to look at today, though, is going to be reverse PEMDAS, which is probably the most common way to solve an equation, is to undo all the things that are happening to x and get the x all by itself. Okay, so we're looking at examples that we can solve by reverse PEMDAS today. So here's an example. This is an example in the book where they're going to ask you to graph, and they're going to ask you to label some things. So I'm very curious about what is the vertex, what is the axis of symmetry, and of course, what are the x-intercepts. When I ask for x-intercepts, I'm going to want that done algebraically so that you could give me exact answers. I had a few groups talk about just looking at the graph. If you graph it in a graphing calculator or in a graphing program like GeoGebra or Desmos, finding your x-intercepts graphically is a totally valid method of finding x-intercepts. Of course, we'd also like to know that algebraic piece. So that's what we're going to look at today. So I got f of x equals x minus 1 squared minus 3. And I say, graph this using your transformations. So tell me what the transformations of this function would be. Eric, what's the transformation of this function? It goes to the right one. Okay. Nina, could you give me the other transformation? Down 3. So we go right 1 and down 3. And that point represents my new vertex, right? So if I label that point right now, I'll have labeled the vertex. Okay, so I could say 1, negative 3. And I could cross that off as something I've done. So if I've got it in this form, I've labeled the vertex. Could you also label your axis of symmetry? Absolutely. Axis of symmetry should always pass through the vertex. So I could go ahead and I always mark mine as a dotted line. There's my axis of symmetry. Vertical lines are x equals a number, so we're just saying here x is equal to 1. It's whatever the x-coordinate of your vertex is. Now, if I was doing a nice graph, let's say it's a problem set, a quiz, a test, I'd like you to find a couple extra points to get a nicer graph, right? I might recognize that there is no vertical stretch or shrink, so it's going to have sort of like the same size as my parent graph. And if I know about the sizes or the change of points in my parent graph, I could use that. And it's still positive, so then my graph is opening up. And so I'm going to start at my vertex. I'm going to say, for my parent graph, I know when I'm usually at 0, 0, to get to the next point, I just go up 1, right 1. So I'm just at this vertex here. I'm going to go up 1, right 1, and up 1, left 1. And if I want some more points, I know that the next point in the quadratic function in terms of its parent graph would be when I do like 2 squared. Well, 2 squared would give me 4, so that means I would go right 2 and up 4. So I could do that for my vertex point 2. Right 2, up 4, left 2, up 4. Now, if you're less familiar with kind of like those rates of change or those different values in the parent graph, you always have the option to just plug in some values for x and see what you get out for y and plot those. Okay. I would recommend on your homework assignment, like pick a couple graphs that you're gonna maybe draw a little bit more nicely than some of the other ones. If you're usually just drawing like quick views, pick one where you actually practice finding those extra points. Oh, I've got my axis of symmetry labeled. I've got a nice shape for my parabola. The last thing I want to find is my x-intercepts. And you guys said set y equal to 0. And solve for x. So before I solve for x here, can you just tell me the different steps I would take to get x all by itself? What's the first thing I would do? Shout it out. Add 3. Then I would square root both sides to get rid of the square. And finally, I would have to, I'd have x minus 1 all by itself, add 1, right? So you should be able to look at the equation and think about, I'm peeling away all the layers of the things that are happening to x. What would I do? Add 3, square root, add 1. Okay, so I'm going to do those things. First, I'm going to add 3 to both sides. Then we're going to square root both sides. From algebra 2, we know that when we square root both sides, we have to add what? Plus or minus, right? You don't know if it was a positive times a positive or a negative times a negative. So that's really important on these problems when you have to take the square root to solve. And then when you add 1, I always put the 1 in front of the plus or minus. Or if I subtract a number, I put the negative number in front. So x equals 1 plus or minus square root 3. This, when I put it in front of that radical, then it looks like what it looks like if I did like a quadratic formula. Okay, so it looks kind of the same way. And that's the exact answer. Note that you could find that as a decimal, whatever 1 plus the square root of 3 is, 2.73. But I'm not really interested in the decimal. I want your exact answer. So now I can go to my graph, and I could label this 1 plus square root 3, 0. And this one must be 1 minus square root 3, 0. Okay? Are we okay with this? Now, the other thing we want to talk about, and I think I had my slides out of order, so I probably wanted to say this before, but is that form that we just saw, where we could use the transformations to help us graph, it used to be called vertex form. The pre-calculus book calls it standard form. Okay, so make note of that to yourselves. This is the new standard form. The old vertex form is the new standard form. Okay. The old standard form was ax squared plus bx plus c. That's what I refer to now as old standard form. Why the book changes it, I don't know. I actually prefer that it be called vertex form because what's staring at you in the face in that equation? The vertex. What is the vertex? HK. I always remind students, H is the opposite of what it looks like in the equation. So if it looks like a positive, it's really a negative. And vice versa. So HK is the vertex. That gives us left, right, up, down movements. A does what? Nathaniel? It does do stretch and shrink. If the absolute value of A is greater than 1, then you have a vertical stretch. So that would mean, like, when I'm thinking about my parent graph and I said, oh, I normally go up 1 over 1. If I have a vertical stretch of 2, then that would change to go up 2 over 1. And if I normally go, like, up 4 over 2, if I vertically stretch it by 2, I go up 8 over 2. So you just apply that to the vertical movement. If the absolute value of A is between 0 and 1, Then you have a vertical shrink. What else can A tell you besides stretch and shrinks? Haley? If you have a reflection. When would you have a reflection? If A was negative. So that's why I have that absolute value there. The number, the positive number value only tells you stretch and shrink. The negative would tell you that you had a reflection. So negative A is responsible for a reflection in the x-axis. And that would mean that your parabola opens down. Okay. Now, here's where I'm going to have to challenge some of you. We are wanting our answers for quadratics to look like standard form, the new standard form. I realize that you have been taught, rightfully so, how to work with quadratics in the old standard form. Does opposite of B over 2A ring a bell to anyone? Yeah. So you have methods of finding the vertex and the axis of symmetry and all of these things for the old version. But we're going to push ourselves to always make sure we're in this form before we complete a problem. This method of getting it in this form is going to be super helpful later on in the year. So here's an example. And I'm not going to do all this stuff, which is graphing and identifying those things. You could do that based on our first example. I'm trying to cross that out, but it's hard for me to find the words. We basically want to write this quadratic function in its standard form. So this standard form is the new standard form. Y equals A times the quantity x minus h squared plus k. And what we have is the old standard form. To get it in new standard form, we need to complete the square for the x terms. Because what we want to create is this group of parentheses that's being squared. And so we're going to create something called a perfect square trinomial. A perfect square trinomial is the same thing as a perfect square number. What's a perfect square number? What's a number that's a perfect square? 9, because it's 3 times 3. So a perfect square number is something that has the same two factors, right? 3 times 3. We want a trinomial that when we factor it, it has the same two factors, like x plus 2 times x plus 2. Okay? In order to get that perfect square trinomial, you use something called completing the square. So a couple of things about completing the square. The value in front of x squared must be equal to 1. On my next example, it will not be. So we're going to have to factor that out first. I write out my work like this. F of x equals, if I factor anything out, I put it in front of my big group of parentheses. Or I have a big group of parentheses where I just put my x terms and I leave a little bit of space because that's where I'm going to complete the square. And that plus 5 I can kind of ignore for right now. It's hanging out in the back and it will factor into my final answer, but I'll just leave it there. Now I just worry about x squared and x, and I've got to complete the square. Does anybody remember how to complete the square? Oh, Brady, you know. You cut the 6 in half, so half of the middle term. And then you do what? Okay, so you multiply it by itself. So half of negative 6 is negative 3. You're going to multiply it by itself, which I would call squaring it. What's negative 3 squared? 9. So the number that completes the square is positive 9. Okay. And I used to have this nice balanced equation. And then on one side I added 9. So what will I have to do to keep it balanced? You could either add 9 on the other side or subtract 9. It's totally up to you. If you want to put a plus 9 over here with f of x, you can. I usually, just to keep everything on one side, will say minus 9. So it looks different, but it's really the same thing because plus 9 minus 9 is 0. And now I'm just kind of cleaning up what's left over. Brady completed the square for us so that when we think about factoring this trinomial, what are factors of positive 9 that add to make negative 6? Negative 3 times negative 3. So when we factor it would be x minus 3 times x minus 3, which we could write as x minus 3 squared. The whole idea of why we completed the square. And then plus 5 minus 9? Minus 4. If you added 9 on the other side, then you would subtract it to get f of x all by itself, and you come up with the same answer. Now I can identify the vertex, 3, negative 4. I can identify axis of symmetry, and I could solve that by setting it equal to 0 and solving for x. So that's called completing the square. Right now, if you don't remember about completing the square, you should write in the margins of your notebook. Take half of the middle term and square it. That is completing the square. Take half of the middle term and square it. Okay, we want to run through one example, and of course everybody loves fractions, so I try to please. I picked a problem with fractions. Okay. We want to run through one example where a is not equal to 1, because you have a little bit of front work to do. Remember that you want to complete the square for the x's. So you're really only concerned about these two right now, and you want to get 1/4 out. So you're going to factor that out. I'd write that outside my group of parentheses. And then when you're factoring something out, it's like you're dividing by that number. So if I were to take this first term, 1/4 x squared divided by 1/4, I'd just be left with x squared. Cool, that one's easy. What about when I take negative 2x divided by 1/4? Negative 2 divided by 1/4? Elias?
Because you just multiply the reciprocal.
Thank you. If you're dividing by a fraction, you're multiplying by a reciprocal. So we'd really just be multiplying negative 2x by 4. Get negative 8x. And I still have that minus 12. I don't factor out that leading coefficient from 12. That 12 is just going to hang out in the back. That's fine. Complete the square. What value completes the square there? Half of the middle term squared. 16, so we're going to put plus 16. And here's where it gets a little bit tricky. If you added 16, but it's in that group of parentheses, what did you really add? 1/4 times 16. You really added 1/4 times 16.
Oh.
You really just added 4. So now to kind of keep your balance, you got to think about, I added 4, now I'm going to subtract only 4 instead of 16. So anytime you factor something out, then you have to remember to distribute it. So we would get f of x equals 1/4 times x minus 4 squared minus 16.
Can we just like use the vertex thing, like negative the other two way, and just kind of find the point?
You could, but we're going to continue to use this later on, and you do need the skill of completing the square and doing this thing where you add and subtract and you distribute. It comes in really handy second semester when we do conic sections. So I know that you can do it other ways, and I am okay with that you know how to do them other ways and you would try different ways. The only thing I'm concerned about is that it's really a skill you want to know, so you've got to practice it at some point. So that's where I'm saying I'm pushing some of us to try this method just so that that's in your toolbox.
Are we allowed to use like finding the vertex, like on top or whatnot, or will you count it off for not completing the square?
Let me think about it. I don't like to take off when you do something right in another way, but I know that I really want you to complete the square. So I'm going to go back and read my directions. See what they say. The last example is, can you write the standard form of an equation given the vertex and a point? And so again, think about this standard form, y equals a times the quantity x minus h squared plus k. What could you do with that vertex and that point to help you write an equation, Rachel? Okay, that's h and k, so we know h and k. What does the point give us? X and y, and so we could plug that into y equals a times x minus h squared plus k. Okay, so we would say 0 equals a times x is -1 minus -2, which is really plus 2, and then minus 2. So all I've done is I've plugged in those 4 coordinates, and now I could solve for a. Does that make sense? Okay. When you're solving for a, follow order of operations. -1 plus 2 is 1. And 1 squared is 1. Notice how I'm writing that. That's 1a minus 2. Don't think that you can do 1 minus 2, because 1 is getting multiplied by a. So then I would add 2 to the other side, and my a value is 2. Plug that back in. Y equals 2 times the quantity x plus 2 squared minus 2. There's my equation. If you wanted to check that, you could plot those 2 points and see if that makes sense. Like, do you have a parabola that opens up? Yes. Does it seem like I have a vertical stretch of 2? Yes. Then I think I have the right answer. Awesome. I know I went really fast through that last example, so I will post a video, and then you could go back and rewatch the video to help you with that if you need a